In fluid mechanics anyway, we usually study two major fluids, liquids and gases. In this presentation, we're mainly going to focus on gases, specifically air. Aerodynamics, by definition, is the way in which air particles behave as they move around and in some cases through the object of interest. The world of aerodynamics is broken into two major industries: aerospace .
Jesus Christ! Woo! Let's see what you got now, Chester. Okay, Bev, let's turn and burn.
And of course, automotive engineering and motorsports. This presentation we're going to go through XYZ airflow, ride height flow manipulation, vortex generators, under trays and aero add-ons, and lastly active aerodynamics.
Now, we will be using the Mercedes-Benz AMG C63 Black Series to demonstrate the XYZ components of airflow in automotive engineering.
So as you can see from this diagram here, this is the setup you would have for basically most vehicles, unless you're driving an off-roader. The ride height of your vehicle from the ground actually allows a small volume of area under the car for air to actually build up, and the green lines, those are the streamlines that you'll see when the air actually blows over and under the vehicle. The smaller volume of air that's available underneath the car allows for a greater downforce created by the air as compared to an upforce. So what that does is the greater downforce, it actually allows your car to stick to the road. It actually allows a good amount of traction in your tires due to the force pushing down on your car. It's what keeps you on the road at pretty high speeds. Okay, so let's look at some of the interesting features on the AMG that do come in different models of cars. To start off with, the spoiler at the rear is used to increase the downforce at the rear of the car to actually improve traction at the back. And now if we come to the front of the car, the front lip of the vehicle that comes in most vehicles with flick, it helps push down and create downforce at the front of the car to increase traction at the front. And for more functional use, the larger front grille and the inlets on the front bumper actually help keep the engine cool, as well as provide air for the two turbochargers on the AMG. It actually comes through the large vents in the grille, and the heated up air from the engine bay actually is released through these cleverly placed exhaust ports on the hood. Now you can also see from the side vents on the front bumper over here, the air is actually taken in and used to cool the large brakes on the AMG, which aren't shown in this model. The heated up air is also released back through these side vents at the front and also at the rear of the AMG. Some of the more extreme features that I just showed you may only come on sports cars, but a lot of these features in one way or the other are applied to a lot of production cars these days, especially with the type of exotic body stylings that they come with. It allows for a lot of these features. Yes, by now you all have probably witnessed it at one point or the other, the stand scene. Probably one of the best ways to take a daily vehicle and give it an aggressive and pretty appealing look. However, it does have a pretty functional use for lowering your car.
What are you doing?
Going old school.
No, not that kind of use either. With newer cars these days, manufacturers have been pushing the boundaries of how low they allow cars to be from the factory. They try to take advantage of that extra downforce to actually get better traction to accommodate the higher speeds people drive these days. Even the new BMW 3 Series, for example, is so low from the factory that it actually scrapes on Trinidadian roads in certain places. Now that was the car manufacturer stock automotive side of the ride height. Where it gets really interesting is when you go into the aftermarket, because a lot of the lowering systems used in the aftermarket scene is actually also used in motorsports, with the exception of airbags. As you can see, the added traction that you actually get from lowering your vehicle, you can do some pretty crazy stuff with it. We're gonna get into the details on the types of suspension systems that I used. That will be for a future lecture on engineering dynamics and handling. But just to show you how they look, we have the cheapest lowering springs, then there are coilovers, and lastly airbag suspension or performance airbags. The decade-old rivalry between Subaru and Mitsubishi spawned a very popular aerodynamic component that is sported on most of their production cars and has become quite a style in the automotive culture, but actually holds a very powerful automotive aerodynamic purpose. Designed to work with a rally-inspired wing, we need to understand that these vortex generators were designed specifically to work with a large spoiler or wing, not without one. To understand how the vortex generator works, we need to look at what happens when there is no vortex generator. So in this diagram, you can see the wing or the spoiler is at a slightly lower level to the roof. Now what happens as air flows over the roof, it drops down onto the wing, and this airflow is the attached fluid. Actually, that is basically the airflow that sticks to the surface of the roof and the spoiler. Now, as that air is attached and it comes off, there's also a bit of air that drops below the spoiler, and that is basically called whirlies. They basically go all over in any direction. It's called separated flow. Now, between the air coming out from the bottom of the vehicle and the top of the spoiler, the separated airflow creates a region behind the car, and this region actually creates what is called drag, and it actually pulls back the vehicle. Now let's put the vortex generator on. This is what happens with the vortex generator. That air, that separated air that was dropping from the roof below the spoiler and was causing a bunch of whirlies, the vortex generator actually allows vortices to be made, and what that does is it actually takes a lot of that separated flow and actually, in a sense, it disciplines it. It actually causes it to become an attached flow in the direction underneath the wing. So you have attached flow now traveling both above the wing and below the wing, and of course you still have a little bit of separated flow left, but it is significantly reduced, as you can see by the smaller red area. What this does is it reduces the drag and it actually improves acceleration. On the trays and aero add-ons, we'll be using the BMW Z4M GT3 class to show you all what it's all about. The undertray is actually a tray that covers the undersurface of the vehicle, and besides just clearly being for protection purposes, it also allows the vehicle to have less upward force acting on it from the air by covering all the crevices and nooks and crannies created by the positioning of the flooring of the car and the drivetrain and the drive shaft and the differentials and whatnot and the suspension. So basically it creates a flat surface and it minimizes the upward forces to make the car more stable. These little fins sticking out here that you can see, these are canards, and what canards do is they basically extrude from the surface of the car to create an extra additional surface at either most of the times the front or the rear to increase the downforce. So basically you have this splitter down there and it increases downforce, and the canards just adds to that downforce generation to increase the total downforce. The rear diffusers you're seeing here actually reduces drag by producing a surface for the air actually coming out from underneath the car to attach to minimize the amount of separated flow being created. The Porsche 918 Spider, the LaFerrari, the McLaren P1, all cars that make heavy use of active aerodynamics. Active aerodynamics is a combination of mechanical, electrical, and computer engineering. All of the topics that we have covered in this presentation, the aim of active aerodynamics is to use mechanical components controlled by electrical engineering hardware and programmed by computer engineers to actually manipulate the airflow when you want it at any point in time to make maximum performance improvements. in a lot of the stuff we covered, like spoilers and whatnot, vortex generators, those things are set to have a sweet spot and be most performance friendly at a specific speed. With active aerodynamics, the aim is to be able to adjust the angle of attack and height of the spoilers, splitters, and even canards. Anything really that comes in contact with the air is basically allowed to move and change its angle and position to basically create the lowest possible drag coefficient for the vehicle at just about every single speed above a reasonably high speed. Now I'm really tired narrating, so I'm going to leave you all to Porsche to basically give you a breakdown on how active aero works.
Winning against resistance is a matter of attitude. For the new 911 turbo models, it is the rule of dynamic driving. A tradition since 1974. And it has a future. With new Porsche Active Aerodynamics, PAA, a system that comes fitted to standard. So something new in a road car. It adapts to aerodynamic requirements with regard to air resistance and downforce, according to the driving situation, the driving style, the driver. The active front spoiler lip and the rear wing can be retracted and extended in 3 stages. Stage 1. Start. Both spoilers are completely retracted. The greater road clearance at the front improves suitability for everyday driving. Stage 2. Speed. From 120 kilometers per hour, the front spoiler and rear wing are partially extended. Agility and driving stability increase. Fuel consumption remains low, and the maximum top speed can be reached. Stage 3. Performance. Activated by the press of a button, with the spoiler button or the Sport Plus button. Front spoiler and rear wing are now completely extended. The rear wing is also tilted. The aerodynamic downforce on the front and rear axle is ideal for high performance on fast and winding roads, or on the racetrack. What you cannot see at the controls is the logo on the spoiler lip when extended. The road holding remains certain, which you can clearly feel. A clear standpoint is really helpful when you want to win against resistance.